Hey, we live there. We live. For the scene, me say I'm seeing you, sir. Are you all hearing me as well? Let's just make sure, because I feel like, yeah, I think we're in the game. Let me just check this. We're in the game there. We're in the game. So here we are getting ready for the final session on algebra. And the two topics that I want to really look at today is variation. You can see it by day. All right, and now we're the variation and inequalities. So being early people, I'll could press like on the video. And here's what I'll tell me which one I'll want to do first. Which one are you want to do first? Inequalities or variation? So these are the last two topics that we look at for question two. Question two, which is mainly algebra. Last two topics. So what are you feeling? What are you feeling to start with today? For some reason, I'm real tired today. I don't know if it's Good Friday, holiday vibes. I don't know if I just need some sleep. But I'm real tired, boy. All right, inequalities. You want to look at inequalities first? Saria says inequalities, Shadrach inequalities. Are you agree with on some group chat or something, or how everybody's saying inequalities? So everybody's saying inequalities. So I have a group chat in the background there where you come together as a team, not a soul say variation. You know? All right. Normally when I ask my class which one they want to do first, I do the next one first, just just to exert dominance. just kidding. Yeah, just to show them that it's not democracy. Just to show them, it's a dictatorship here. I run in the show. But all right, I'll do the inequalities first. So inequalities, the first thing with inequalities, you want to, when you're mapping out, so there you here, and when you're mapping out inequalities in your mind, you want to kind of, the topic of inequalities, you want to kind of keep it in the same spot that you keep. It's basically same as normal equations. Except for two things. We need to look out for two things. I call them the trap cards. So you have to find out what the trap cards are. Some of you all may know them already. So you're operating like normal equations. I mean normal transposition. Like if I give you 3x plus, if I give you 4 minus 3x is equal to, 13. How does this work? You'd say minus 3x is equal to 13 minus 4. You get 9. You get negative 3x. You get x is equal to 9 divided by negative 3. X is equal to 3. Negative 3. Rate out of 10 how much you understand that. That's normal. So this is normal equations, right? Normal linear equations. Inequalities are very similar to that. You use the same concepts. It's just two trap cards you have to look out for. I mean, you also need to understand the principle of inequalities with the number line, but that's something else. But it should be 10 out of 10 for this, right? So the two trap cards, are you ready for the two trap cards? Is if you swap both sides, and I mean the entire sides, right? The entire left-hand side swap with the right-hand side. Not just bringing across something and don't go and overdo it. If you swap both sides, there's one trap card, and the next trap card is if you multiply or divide by a member of the race of negative numbers. If you multiply or divide by negative numbers, you also activate this trap card by negative number. I should have an A in here somewhere. So what does this do? This results in a tiny matrix, and you might get a glimpse of the real world. Of course not. This what does this do? This causes sign, and the sign I'm talking about here is the inequality sign, and not no negative sign, positive sign. It causes the inequality sign to reverse or flip. right? So it causes your inequality sign to reverse or flip. Now that's just a theory. You can write that down only after we do the questions. Or those of you who understand what I'm talking about already, this makes perfect sense, and you might say, "Wow, that's a beautiful way to express it." Yes, that is why my channel 120,000 followers. Impressed with the humility. All right. No, but it's really a nice way to express it, and just keep it right if you understand what I'm talking about. For those of you who don't understand what I'm talking about, and you want to enjoy the show and understand the plot twists and see all the questions and things, you will see it. You will see it as we jump into the actual questions, right? So this is the little nugget that you want to keep. And now let me tell you something. All 140 of you all here. First press like on the video. And let me tell you something. You need to be extremely paranoid about this. And I'm pointing this way. Yeah. You need to be extremely paranoid about this. So he should not be like this. He should be like this. Even some of the top students, I see them leaving out this, So this is something that needs to, you need to be paranoid about it. I shouldn't say paranoid. Paranoid is so negative. You need to be on the lookout for this. Don't let it pass you by. And you'll see as we do some of the questions how CSEC will sneak in these trap cards into this. More about inequality. So let's just touch on some more theory before we jump into those questions. The basics is when they involve like number line. Anybody don't know what a number line is? If you don't know what is a number line, just close this video. Don't even bother. Just next year fate. If you know how number line is look by now, next year fate, next year fate. It was nice. You could just watch for entertainment from now on. Right? So like they could give you x is greater than, and you call this x 8, 9, and you could say x is greater than 2. So on a number line, you look for the 2, you parallel 0, and you point the arrow here. You're kind of showing we including all values greater than 2. Some people is going to think the arrow, where the arrow stop is of importance. That's not of importance. I could have light stop here. I could have light stop here. Don't worry yourself about where the arrow stop is. Study where it begins, not where it ends. Philosophy. And notice how the circle isn't shaded. If I put this, now I'll have to shade the circle because this means greater than or equal to. So it means I'm including 2 in this. So far, so good. If you understand everything so far, say, I understand, sir. Don't worry yourself. So I could copy and paste the number line because, on a computer, and I could do these things. And I could draw something like this. And now you know that is telling me x is less than 4. Good. And I can draw something like this. And I can do this to this. Now, if you look at this carefully, you'll notice 2 starting points occur. 2 starting points exist. So I'll have to put the -2 and the 5. And this is the sandwich thing. So you express it as one algebraic statement, one line. So boom, bang, bang, x. This is basically saying x is more than -2 or equal to -2, but at the same time, it's less than 5. This is a multiple choice question here. This is a multiple choice question. You're going to see this in the exam. You heard it here first, ladies and gentlemen. So I could also have it set up like this. And maybe hit them as boom, hit them as shot there, bang. Let's make this one shaded. We have 2 starting points, but we also have 2 regions. So we'll express it separately. We'll say x is less than 0, comma, x is also more than, x can also be more than or equal to 5. Read out that 10 how much you understand everything in this kind of diagrammatic basics idea here. Now, for those of you all who are struggling to understand the difference between this symbol and this symbol, let me bring you up to speed with the rest of the class. If I, as a teacher, standing in front of the class and the students are sitting here, and I don't know, we selecting students for some kind of some kind of activity, and where my board gone by? Alia still see my board? Okay, it didn't affect Alia, it affected me. Yeah, and I ask you all to tell me. No, I say everybody who is under all the under 16s stand up. All the under 16 stand up. If they use it on here and you are 15 years old, do you stand up? They use it on here. If they use it on here, right? I don't know what's going on with you here, but I use it on there. If you are 15 years old, do you stand up? Oh, my board did cut off from you. Just a second, eh? I real drawing and thing and then see my expert diagrams. That you, if you are 15 years old and I said 16, what I say, right? Under 16, I forget what I say. I don't make it up again now. So if I say under 16, stand, and they you here and you know you are 15, do you stand? Well, yeah, you understand you're under 16. If you happen to just turn 16 all of a sudden, do you stand now? No, because they're not under 16. So this means, this is when I say under 16, I'm saying X is less than 16. Now, if the teacher say 16 and under stand, oh God, you're back in the standing pretty now. 16 and under means X could be 16 or less than 16. So you have to rise and shine. So it doesn't mean, like some people kind of overthink it, boy. It has some things in maths you need to think a lot and some things you don't need to overthink a lot. Allocate one brain cell to the understanding of this. Don't overthink it. 16 and less than or equal to 16, it means 16 going down the road. It don't mean whatever, some abstract things that is pulled out of the hat for this, like the person have to be 16 and then it has somebody who wants some weird things that is getting on your mind for this point. Don't do that. So X is less than 16 would include this set of numbers. You understand? 16, 15 going down the road. X is more than or equal to 17. What will it include? It'll include this number 17, 18, 19 coming up the road. I don't know why I changed color like that, but you know what I mean? 19 coming up the road like that. The 3 dots in maths mean and so on. Read how you understand. Oh, anybody can tell me what is this place here? That at time 2-3 years ago, I had one star different school backgrounds, and we was playing a game of guess the school background. So they can guess what school background is this. If you're going to school, good luck. You probably have an advantage on me. So, but you'll understand. So, like if I said X is between 3 and 8, what are the numbers that I would list out here? What are the numbers do I list out here? No, partner, there's no 5 rivers. What's the numbers I will list out here? X is between 3 and 8. What are the numbers I list out here? Right, good. From the time you say 3, have several seats. 4, 5, 6, and 7, not 8, so I could bring in this. You understand? Because I didn't include these guys into the party mica, so what they doing there. If I put this then in, and only then I could sneak in a little trios on them right there. All right, enough talk on the basics. Time to get into the questions now. We're getting fed up. Remember, this is the most important thing that you have to be paranoid about. This guy ain't looking paranoid enough. This guy ain't looking paranoid enough. You need to be real wary about these people. So you see, you're always on the lookout for this in the exam. You're now starting to get it. These 2 trap cards where you need to swap both sides, where if you swap both sides or you multiply or divide by a negative number, the sign reverses in inequalities. So let's begin. We're going to do some past paper questions here. Test out your knowledge. Solve the inequality x minus 3, 3x minus 7. If x is an integer, d to blah, 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 blah. The extra maths. Let me do the first maths first. So x minus 3 less than 3x minus 7. Bring across the 3x, x minus 3x. Bring across the negative 3, negative 7 plus 3. You understand that? Right now we operating in the realms of a normal linear equation. We didn't activate any trap cards. All you feel the trap cards activate there. Did we swap the entirety of sides? Did we multiply or divide by a negative number? No, we didn't. We did not. We did not. So we continue as normal. X minus 3x is negative 2x less than negative 7 plus 3 is negative 4. We are about to do something here that is going to activate that trap card. But pause raise all your pause supposed to be raising too. All you feel that shift in this, you feel that shift in the university, all you feel that shift. You better feel it in the exam. You have to know what we just do. We just divided off a negative 2. We just activated a trap card there. We divided by a negative number. The rule says when you do that, bro, if you want to keep your marks, this is where you have your marks here now. If you don't cross the threshold and switch this here, you're starting to say you don't want your marks anymore. So x is greater than 2 is the answer. That is it. You see, one time, first past paper question, we do it at a trap card in it. Maybe for we have some really smart students here, maybe like you want to feel, why is that a thing? That don't even make sense. Yes, it makes perfect sense. To keep the logic of the statement, you have to swap the card, the sign. Otherwise, you're breaking the laws of mathematics. Let me show you why, right? Let me show you. If I told you x is a number, or negative 2 times x is greater than 4. Take your time. Think of a number that will satisfy x. Think of a number that we could put in there that would make x true. I'm picking the first correct number you all see. Think of a number that we could put in there that makes it true, make that statement true. Lob. Let me pull Lob. Lob just tell me something. I want to come back to what he see. Somebody say 2. 2 is not correct. If I put 2 there, I get negative 2 by 2. So 2 does not work. Negative 2 by 2 is what? Negative 4. In what world is negative 4 greater than 4? If I put negative 2, it still doesn't work because negative 2 by negative 2 is 4. Better, but 4 is still not greater than 4. Dylan has the first correct answer. All you could have picked an infinite amount of answers, but negative 3 is the first one. So we understand why negative 3 works. If you understand that negative 3 would work, say, I understand, sir. If I put negative 3 inside, I'll get negative 2 times negative 3 is equal to positive 6, which is actually greater than 4. If I put any positive number inside, it does not work. So anybody who say a number without a negative sign, it wouldn't work. I'll get a negative number. Negative numbers are not greater than positive numbers. That is not how it works in the world of mathematics. So you understand why negative 3 going inside there works, right? It works. So we had to put in a negative number. So we got negative by a negative, make a positive number, which is greater. And it has to still be greater than 4. It can't be like negative 2, because it would only make 4, which is not greater than 4. I didn't have an equal to. And I just... So good. Now what's something? If you decide to, and you're going to make an error here, right? We're going to do an error. We're going to keep these signs. It's an error. I want to make sure that you know this is an error. If you decide now to bring across the 4 over the negative 2 without switching the signs, again, x is greater than 4 divided by negative 2 is negative 2. You are telling me that answers greater than negative 2 work. That is an error. That's not true. We already established negative. Okay. X is greater than negative 2. What is greater than negative 2? Negative 1, 0, 1, 2, 4. But we already established that positive numbers will not work inside this. I want to follow you following the logic there. Which is why when you are dividing by a negative number, to keep the logic of the inequality sign, you are effectively swapping it. You're switching the direction. This works. X must be a number that is less than -2. Like -3, which we already established works. Or -4 or -5. So hopefully that help you feel a little better about that trap card, especially the people who like to know the reason behind the rule. If you don't know the reason, if you don't care to know the reason behind the rule, forget the last 3 minutes, but remember everything else. If X is an integer, determine the smallest value of X that satisfies the inequality above. This is the inequality. The inequality is X is greater than 2. And now we want the smallest value of X. The smallest value of X that satisfies this. What is the smallest value? Integer value. Somebody say 2.1. Lisha, go back and review what is an integer, Lisha. That is a decimal number. That's a real number. That's a rational number. It's not an integer. It must be an integer. It must be a whole number, positive or negative. I'll remember the thing. You have natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers. Anyhow, so 3 is the answer. X is equal to 3 is the answer. Those of y'all who saying 3, yeah. X is equal to 3. That's the smallest value right above 2 that could work. Now somebody said, instead of going through all of that, you should have just bring across this X. Look him right here. Read that comment. You see why? So why not keep all the X's positive to save yourself the trouble of remembering the inequality rule? Well, there's 2 inequality rules. There's 2 trap cards. So you think you're escaping one trap card and it have a next trap card waiting for you there. Let me show you. So what some people do is have X minus 3 less than 3X minus 7. They know if they bring across this, they will encounter negativity and they want positivity in their life. So they bring it across this way and they bring this across this way. So you have -3 plus 7 is less than 3X minus X. Why is in the chat? If you're following, you understand? They bring the X across the next side, 7 across this way. So it signs everything proper. No trap cards activated. Feeling good. 4 here. 3X minus X. 2X here. Boom. X divide by the 4 by the 2. Boom. 2X. Nice. No trap cards activated. And then these people, usually, some of them know the rule. They come and this is an error about to do here. Look out for this error. They come and say, well, great. X is less than 2. We already know that wrong because we already know the error. This is the correct answer. This wrong. What trap card we activate here, ladies and gentlemen? Because you know you like to pay X on this side. We always X behind. Not forward. So you know your X here. So you decide to swap the entirety of the left-hand side and the right-hand side. Paul's supposed to raise there. You're supposed to feel a rift in the matrix. Are you feeling it? You swap the entirety of the left-hand side with the right-hand side. So if you swap the sides at the same time, you swap both sides, you must switch the sign as well. So this sign now swaps like this, and now we get this. Once again, for those of y'all who want to know the reason, the rationale behind this, it's very simple to see. It's very simple to see. This, when I write this like this, I'm saying whatever is in the box is greater than 2. If I decide to put the box on this side and leave this, these two things not saying the same. This is what number can fit here. A number like 3. Can I put the number 3 here? This is saying 2 is greater than whatever in the box. So anytime you swap both sides, guess who must take a swap to maintain the logical accuracy of this statement? The sign. Now making sense here? You see how very easy it is? So the 3 needs to come here. And the sign would switch. If I left the sign, I would be saying 2 is greater than 3. And we all know that that will happen in this planet. All right, enough talk. Let's go on to the next question. Solve for x where x is a real number. So let me expand now that. So 2x minus 12 plus 3x is less than or equal to 8. So far, so good. 2x plus 3x is 5x minus 12 is less than or equal to 8. Bring across the 12. So far, no trap cards activated. I am a professional at seeing the trap cards. Don't worry, you're safe with me. 20, 5x. X is nothing. I sense nothing. Pause did not raise. Pause did not raise. While your pause raised, my pause did not raise. I mean, feel nothing earlier. So we didn't activate any trap cards. So don't get frightened and think, oh, good, I bring across a negative number. Switch the sign. Calm down. Have several seats. Only if you swap the entirety of both sides do you switch it. Only if you divide or multiply by a negative number do you switch it. You just brought across something, big man. You're just bringing across things. You ain't doing nothing there. So x is less than or equal to 4. It remains like that. So let's just follow again. 2 by x is 2x. 2 by negative 6 is negative 12. There's a 3x here. The 3x merged with the 2x to get 5x. Negative 12. The 8. Or we brought the negative 12 across to me. The 8 it turns positive. Addition. Or subtraction it turns addition. 8 and 12 is 20. So bringing across the 5 now to meet that 20, we get 4. So x is less than or equal to 20. There we go. Hi, Cindy. What's up? Use the number line. Show your answers. No problem. So we just, firstly, we draw the number line. 0. I could maybe train a little negative 1 there just to show them I know to draw number lines. 2. Nah, sorry. I need that last space there, bro. Sorry. So I will hit them at 0, 1, 2. Oh, no. That's good. Negative 1, 0, 1, 2, 3, 4, 5. I just put 5 there for kicks. I come here now, circle this, hit them a little shadings because, you know, x is less than or equal to 4. Not going to point this way because I want my marks. I'll point this way. Rate out of 10 how much you'll understand this question. So far, so good. Niceness. I'm going to take this man comment off my screen. Now, me real smart boy. Why I mean how we didn't change the sign? We didn't activate that trap card. Well, you see us doing anything here to result in a switch of signs? When? Where? We divide by a positive number. We brought across numbers. We didn't swap both sides at the same time. All right, let's go on to the next one. So this was part 2 here. Next one, solve. We could probably have an admin session sometime in April. And of course, there's the student hub crash course, which you should be registered to by now. 2x minus 7 is less than or equal to 3. Bring across the 7. It's negative, but don't worry, that's just bringing across one number. So you get 10, 2x, x is less, 5 again? Come on, man. CXC, change it up a little bit on them now. 2. So if x is a positive integer, list the possible values of x. So, are you sure about that? Fine, I can list it like this. So x is equal to the set of numbers starting at 5, 4, 3, 2, 1, 0, negative 1, and so on. I just went to negative to show them that I will just keep going back. No, Sadia Bizram, don't make up your own rules. Just follow the people them rules. Follow the rules we have set here from time immemorial. If you swap both sides, meaning the left hand side or the right hand side, you switch the sign. If you multiply or divide by this negative number, then you switch the sign. That's it. You had to put the and so on. You had to put them 3 dots, otherwise you ain't getting no marks. You had to put the dot. All right. Let's do our next one. Solve for x, where x is a real number. All right, we're going to enter some problems with this one, I think. 8 minus x is less than or equal to 5x plus 2. And then we have to show the solution here. Ready for you. See how much time they bring in that number line for 1 mark. So make sure you know how to do your number line thing. So we're going to bring across the x. Don't frighten. Then you can bring across the 8 one time. So you have negative x minus 5x 2 minus 8. Now some people get frightened and switch the sign. What you're switching the sign for? I tell you the rules. The rules is if you swap both sides at the same time. We just bring in across individual terms. I didn't take this whole thing and put it here and take this whole thing and put it there. If I did that, that's when I swap the signs. So some people would do that in the beginning because they want to escape the negative x, switch the sign one time. You can't run away. You can't run away from the swap signs. They have the trap cards they're waiting for you. So negative x minus 5x is actually negative 6x. 2 minus 8 is negative 6. Ending up, what we're going to do here, folks, all your sense in the shift in the energies. You understand why I'm switching it like this? I just divided by a negative number. So now x is greater than or equal to 1. Boom. Make sense? So now we need to go and show this here. Where 1? Okay, move over here. Circle him like this. Shade him in a little bit. Look for arrow, find the arrow and make sure you find it pointing in this direction. Because it's greater than max. They don't give you so much marks for this nowadays. 2 and 1 marks you get in there. Not 3. Like back in the days. Solve the inequality. 3 minus 2x is easy thing. So 3 minus 2x is greater than. It's starting to get repetitive now. That means you're understanding it. 5 minus 3. 2 negative 2x. X divided x is greater than 2 divided by negative 2. This is greater than negative 1. Show on the number line. Find back that one. Circle it. Go so. Bang. Notice I'm not shading it. It had no equal. It was missing the equal. Rate out of 10, I'm sure I'll understand this type of inequalities now. You probably wait to come for the exam, all kind of thing. Well, boom. Take care, understand all of that, and then wang. Wow, this come and show up here. What you gonna do? Don't panic. You can do 2 things. You can treat it as 2 separate equations. So like I can do this. And then do this. And work down with everything. Keeping x on this side to the end. In the end, see what you get. And then keep x on this side. See what you get. So that's one way to do it. The more skilled way, and I don't find it that hard, is to work with it with the 2 inequality sign. So I wait, I don't know. Come closer to the screen. You focus now. You have the game controller in your hand. You know? You get serious now. Lean forward. Because we're going to do some pro movements here. We're going to be working with 2 things at the same time. Now you need to properly understand how linear equations work to do this, right? We're going to multiply everything by 3. What does that do? Won't that get rid of this 3 here? Which is a good thing. So you have 2 minus 4x. And if we multiply everything by 3, you will take a multiply by 3, you end up on negative 3. You will take a multiply by 3, you end up on 15. So far, so good. You understand how we could work with both now? Maybe you're feeling it now. You're feeling the confidence. We had to get rid of that 2. It's adding on and not subtracting. This negative sign belongs to the 4. So to get rid of this 2, we'll need to subtract 2 from everything. So let's go ahead and subtract 2 from everything. If I subtract 2 from this, I'll get negative 5. If I subtract 2 from this 2 goes. So I'm good to go. I just end up with negative 4x. It's less than. If I subtract 2 from this, I get negative 13. So you forget to put it on negative 1 in the number line. Did I put it on 1? Oh, shucks. I put it on 1. Should be a negative 1. I blame it on the sleepiness, and I really want to thank Aaron for that, boy. Thank you, boy, Aaron. And I feel sad watching over this video and seeing that. Yeah. So anyhow, so let me go back to this one, and it should be positive 13. Why did I put negative here? Just 13. All right, let me lock back in earlier. So yeah, we multiply by 3, we have 2 minus 4x, we bring across the 2, so we subtract 2 from each side. This isn't looking too good enough. Let me see if they ask me anything afterwards. No, just 3 marks. Determine all the integer values of x which satisfy the inequality. This ain't looking too good earlier. Fine. Let's keep going. So we need to divide both by -4. And Shakira, I hope you mean you're on a mountain or something. Eh? So we divide both by -4. Are you feeling that? I literally have divide by a negative number. What I mean? Both of these signs win and switch, you know. So if I divide this by -4, both of these signs have to switch. I'll get rid of the -4. This will turn to x. This will turn to -5 over -4. And this will turn to 13 over -4. By the way, if you didn't swap signs, the equation will just like not make any sense whatsoever if you don't swap the signs. Because, okay, -5 over -4, think of it as a decimal. This is 5 over 4. This is actually 1.25, right? I think so. Is greater than x. And think of this one. How much times does -4 go into 13? 3 times. Well, -3 times. So this is actually -3.25. See how this makes sense? It's saying x is greater than this negative number, but it's less than this positive number. If I left these signs, that wouldn't make no sense. If I leave these signs up, keep playing this direction, it wouldn't even make any sense. It will be saying that x is greater than this. Okay, so it's like 2, 3, 4, but then it's less than this. You understand? So you had to swap the signs when you divide by the -4. So this is not pi, by the way. Somebody says fine. Pi is approximately 3.14. That's not the accurate value of pi. Anyhow, so what are the numbers here that satisfy this? You need to think about the number line, -3.25 all the way up to 1.25 on the number line, and you want integer values that work for this. What's the first integer right before -3.25? -3, right? Then -2, -1, 0, 1, 2 gonna be here. Not drawn to scale. 1.25 gonna be there. So what are all the integers allowed? You get it there, boy, Joseph, boy. What are all the intervals are allowed? All the integers allowed. Oh yes, father. So all the integers would be -3 is included. They say positive? No, they want all the integers. Integers could be negative as well. Nobody can give me the correct answer yet. All the numbers allowed. X could be equal to -3, -2, -1, 0, and 1. Remember, you say -3. I thought you said not equal. So why we? Well, this is -3.25. This is a little above -3. So yes, we're not including that, but -3 could work. Yes, Bradley, correct. He's asking if his past paper is based on any integers. Inequalities, yes. All right, let's speed it up. You need to catch variation too. Solve the inequality 12 minus 4m, 5 minus 8m. Bring across this, you have -4m minus 8m less than or equal to 5 minus 12 less than or equal to -7. -12m. M is we're going to have to switch the sign. -7 divided by -12. Or you'll do all of these already. So -4m, -8m. Oh, sorry, plus 8m. Well, yikes, I brought across a negative number. So this is 4m here. So I have -7 divided by positive. Oh, no trap cards, no trap cards. No trap cards. Let's just double check again. When I brought across the -8, it turned to +8. -4 stays there. Brought across this 12, it is -5 minus 12 is -7. 4m, bring across the 4. Yep. Looking good, looking good. And that's the end of inequalities. I feel like I rarely explain inequalities day. You can watch over this again to take in. I'll show you behind the scenes. We went and looked behind the curtain. We sweep underneath the chair. We lift up the bed, put back down the bed, put on the sheet, take off the sheet, put back on the sheet. We do real things with inequalities there. And we do past paper questions so you can, sample your prowess. Next up is variation. So variation, how I teach this is like, how I'd introduce this to them in school, boy. You all remember the time it had these bunch of memes going around, and the thing was the red flags. Was a red flag and a green flag in a relationship now? I am very tired, but we still going. What's a red flag in a relationship? Where's red flags? I'm bringing up my variation questions here. I'm bringing them back up over because my board's starting to stick. What's a red flag in a relationship? If somebody doing that, that red flag. Did variation come last year? I can't remember right now. Miss Nalini's know them thing often. I just forget. I mean, I do the solutions, so you can go and check it out. Me and Adaptation do the solutions live on YouTube. Not knowing how to do maths. Gal can cook. Gal on the hole. Not knowing how to do maths. If she have a boy best friend. That is red flags. So no girl and say no red flag here, boy. Only on the phone. Secure, use the red flag champion. Unfaithful is a red flag. Well, yeah, that one kind of obvious. I mean, what's the flags you see before that? Before you see those, what would be a red flag? Now we don't have the industrial tech crash course. Yeah, everything else, bro. Always too busy. Have too much female friends. Female friends. Hey, don't want to look for work. All you can believe who is this saying this here, boy? I'm gonna be on my best behavior. I was going and say other things, bro. What are you doing here? All right. So I had to be careful now. While there are people on the stream. A red flag. A red flag would be like, yeah, all those things. And let me call this the love axis, and it's time. If somebody is showing you red flags, the love. Let me say they're showing you green flag. What's a green flag? Let me talk about the green flag. Since a certain person on the stream here now, boy. Since a certain person on the stream, what's a green flag? Give me some green flags. Give me some green flags. Give me some green flags quick now, man. A man with money. That's a green flag. Let's talk about green flags. We talking about the topic variation. We're talking about the topic variation. Faithful, good with family, fast response on the phone. Again, a quick response. God-fearing, when the man taking control, people pouring out themselves in this math session here, boy. People bringing out their whole thing right down in the diary. You crack open your diary there. Very give me attention. A manly man could cook, pays attention to things, not a teacher. Maths is a red flag. Nah. Good sense of humor. All right. So, what I tell my class, variation is like that. If you're in a relationship and over time persons are giving you green flags, what will happen to the love? The love will grow, right? Love will grow. And conversely, if the love reach here and as time go on, you start to see red flags start to appear. Not looking for work. Not answering you on time, no attention, no da 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 da. No, all these other red flags that are not good in maths that are called. Then what will happen to the love? The love will die and it will come below a certain threshold. This is the threshold here. This is the we done threshold. So you see, you come here, relationship start growing, but then you start your red flag behavior. So yeah, they hit the road now. Bang. Right? So this is variation. But variation, when it's direct like this, it goes up with a straight line. Inverse like this, it goes with a curve coming down until this, from when it starts to reach this level, there's delete, block, forget you exist kind of thing. You're below. It's not even acquaintance anymore. Anyhow, so the table below shows values of. I want to show you all how to compartmentalize this so that you get good at it. The first key, the thing that you're always looking for with variation, and they see anytime you see the words proportional or varies, that is the giveaway, right? Proportional or varies, that's it. So the key is to first look to see which word you're seeing. Are you seeing the word inverse or direct? So that's the first key. The next key is to know that you're solving for K. You are solving for K. What is K? K is a text you don't want to see when you just pause your whole message. All right. K is the constant of proportionality or variation. Proportionality. So that's the key there. You're solving for K. Now, if it's inverse, K will be found using this. Y is inversely proportional. So whatever X, it may not be Y and X, it might be M and N, it might be something else. But K will come in here on top like this. And they usually don't bring inverse, but it could come. It has come a few times. If it's direct, now some of y'all who never do this topic before, this is making 0 sense there. Until we start to do the questions, it will continue to make 0 sense there. But take comfort. Keep watching. You start to catch it now. You start to catch it. Y is proportional to X, so Y is equal to the K is here. Now remember what the idea is. The idea is to see whether it's inverse or direct, to know which equation to use. Ignore this. Is to know which equation to use, and you find out K. And once you find K, you solve basically on your way to solving the rest of the question. Easy, easy, easy. Are you ready to jump into the question? You'll see me do this over and over again for how many questions I have? 1, 2, 3, 4, 5, 6. 5 questions. You'll see me do this for 5 questions. I think this is the most 5 recent questions. Those who only saw this episode, please tune in to the days before. It may not look like it, but it's a very valuable 5 days that I just did here in terms of algebra. Question 2 in the maths paper. So you can press like on the video, don't frighten with the like button. The table below shows corresponding values of the variable X and Y, where Y varies directly. So they said directly. So I already know I'm dealing with this fella here. Y is equal to KX. Calculate the values of A and B. The key is to find K. The key is to find K. So how do you find K? To find K, use known values. This is the journey for K. What is one column here? Column 1, column 2, column 3. Which column has 2 known values in them? Obviously, it is column 1. And you want to use, when I say use, I mean substitute. So when y is equal to 12, x is equal to 2. Well, you see new flow, new working. So therefore, substituting into this, how do I know to use this equation? Because it said directly, it will be 12 is equal to k times x, which is 2. You also understand the substitution there? See the substitution? So k now is 12 divided by 2, k is 6. I want to see, once you figure out what k is, I could write k is equal to 6 like this. We're not in the inequalities land, we're in equal land. You could swap it around without fear. So k is equal to 6. Once I figure out what k is, I basically solve the question, because now I know y is not equal to kx. Well, it is, but I know that k is 6, so y is equal to 6x. So this is basically saying a very simple idea that y is always 6 times whatever x is. What is a now? And now I'm working to show faith. Cindy, and you see now I could flow out a working from this. When x is 5, y must be 6 times 5, 30. This is 30. Y is 6 times that. When x, oh no, when y, this is y now, is 48. I'll need to do a little reversal here, but that is okay. 48 must be equal to 6 times whatever x is. By the way, this y here was actually a is 30, and this x here is actually b. So I can substitute b one time. You all understanding? So b is equal to 48 divided by 6. How much times 6 go into 48, boy? Hopefully it's 8 times. B is equal to 8. Time to try next one. You all understand the flow of a proportional question? It has never come different than using these techniques. Never have come different. Sometimes it may not show a table. Sometimes it might just be words. But it's always using known values to find k, using the y is equal to k over x or y is equal to kx. Always. So the table below shows corresponding values of variables x and y, where y varies directly. Again, varying directly. Boom. So y is equal to k times x. How do we figure out what k is? Use known values. When y is equal to 3, x is equal to 6. So 3 is equal to k times 6. K is equal to 3 divided by 6. K is equal to half. You all understand? We just found k. Once you find k, you find everything. Look at it. See if it makes sense. Y is always a half of what k is. So now we can easily figure out this, and we can figure out that. Mentally, we can do that. Mental maths could fly in here now. But anyhow, let's do some working. So when x is equal to 10, this y must be equal, or this y is called u right now. U is equal to not k anymore. K is a half of 10, which is 5. And when y is equal to 9, this 9 is equal to a half, not k anymore, a half of t. So what that means? A half of t also means 9 is equal to t over 2. Bring across the 2, it means t is equal to 18. Let's check. If this is 18, half of that is 9. If this is 10, half of that is 5. It works. So they used to bring it real easy like this. But I find these days they're bringing it with more complicated keys. I don't know if it's because I have a nice video on YouTube with this. So like I explain it really well. Anybody could understand it. So they're like, maybe we should make it more complicated now. Because people used to get this question wrong for no reason. I think they used to get this question wrong because they just didn't understand how easy it is. Or they didn't have a nice, easy framework of just understanding the question. So let's see how things can get more complicated. The force F is going to be the same idea, but just more complicated numbers. The force F applied to an object is directly proportional to the extension E produced by that object. So the force is proportional to the extension E. Directly again, yes. You know, this is always directly, but inverse could come. Represent this information. Some of you all have this habit. I'm not saying you, Mr. Doc McDuckins. I'm not saying you, sir, but The reason why some students ask this question is when they figure it out mentally. Like, you see what I'm saying now, and it becomes so easy. Like, that is what it is. Yeah, I don't need to show working for that. I don't need to learn the working idea. That's laziness. Yeah, not you, Mr. Doc McDuckins, but it's other people. When them ask that question, it's usually laziness in the system. I tell you, it's usually a kind of laziness holding on to the system. Do I really need to show working? I can do the working, bro. The reason why I want to learn the working is one, it helps to structure your critical thinking for all the other types of questions, as well as sometimes it could come crazy. You'll see, it could come with some weird keys and things. So I'm not saying you were Doc McDuckins, but learn to send out your proper working. Man say no, it's me. All right, so F is proportional to E. Represent this information in terms of F, E, and an appropriate constant K. So if F is proportional to E, therefore F is equal to KE. The incomplete table below shows corresponding values of F and E. Use the equation obtained in C1, this equation, to determine the values of F. So same thing again. Same thing again. Once it's long words. Once it's long words, same thing again. Use the known values. When F is equal to 8, E is equal to 0.2. Since F is equal to KE, substitute 8 is equal to, we find in for K is always find for K in the beginning, 0.2. So K is equal to 8 divided by 0.2. Put it in your calculator and sure enough, K will be equal to 40, I think. So I can see. So K is equal to 40. When you divide by a fraction, the numbers go up. This is like 8 divided by 0.2 is really 1.1 over 5. The 5 will come and meet the 8 and you get 40. Check it and see. It's somewhere, but it's true. And then F is now equal to 40E, right? So when F is equal to 25, 25 is equal to 40E. So now E is equal to 25 divided by 40. I don't know what that is. Go through the earlier. So this, in this case, this E is X that we're trying to find here, right? You understand? 25 was substituted for F. And when E is equal to 3.2, you understand? I'm going to hunt for the Y now. Because once you find K, you find for everything. F is equal to 40. Somebody saying it's 0.625. Not next week, Michaela. Most likely I won't be able to do it next week. I'm real busy next week. The tiredness on my eyes will be way too high. Right now I can still push through. 40 by 3.2. So this turns out to be 128. Okay, fine. If 128 is the call. Any units we're giving here? Well, force is in newtons and E is in meters, but they weren't given. Next one. The distance needed to stop a car. So what is different about this one, guys? This one is a little, they realize everybody's starting to understand this variation thing. People only always getting this question correct. Night and on tomorrow, Sunday. Yeah, the aliens who come on the live just now. If I start to put thing on tomorrow and Sunday, could have problems. I don't know what that name was doing on the live in the first place. It's what was different. One, yeah, so it's no table. We didn't have the table set up from before, so it's worded. And there's something else that's different that a lot of people miss. Read the question. The distance needed to stop a car D varies directly, so we know it's directly again. So D varies with S. They also give units. So D is equal to KS. Is this it? Is this it? No, what was difference is that they didn't say D varies with S. They said D varies with the square of the speed. So ladies and gentlemen, you're supposed to put a square here. Real people get that wrong by. So maybe if you do it in your mocks, maybe you get it wrong too because they didn't put the square there. Yeah, to see what variant what. And then you continue like normal again. So instead of giving you a table and you have your known values at the start, the first column, they actually just literally tell you what the known values are. A car traveling at a speed of 70, distance 40. Check and make sure the units is the same, so fine. Cool. So when S is 70, D is equal to 40. We're going to find for K. Are you ready to find for K? So S is 70, K, this is in the spot of D. So D is 40, K by S is 70. Don't forget to put the square. 40 is equal to K. 70 squared is 4900. 7 by 7 is 49, right? So K is equal to 40 divided by 4900. I don't know if Naomi wrote correct with this one. I'll double check and see if she's correct. She's saying K is 0.001. Is that true? So now they want you to find one unknown. When S is 80, what is the distance needed? Well, oh, by the way, the unit, this have a unit, sir, but it's not important since they never asked you about K. But the unit here would actually be distance over speed. So kilometers per kilometer per hour. Kilometers per kilometer per hour. Which will end up switching back the hour. 0.01. All right, so D is equal to, we want to know what is the distance now. So D is equal to K. We just found K is 0.01. And we put 80 squared here. And we get the answer and we go away. A lot of work for 2 marks. A lot of work for 2 marks. What's the answer? 80 squared by 0.01. Are we taking the correct answer? I've seen some people saying 0.0081. What is that? Oh, this was actually 0.008. I'll make him have to work this out now because I'll again miss some weird answers there in the chat. Which is 40 divided by 490. Let's set him up there, man. 0.0081. So it was 0.0081. Now we're not rounding that off now. We're leaving that so. And now I want to multiply that by 80 squared. Well, again. See if you're wrong, it off, you get a weird answer. I think again about 52 now. See if you're wrong now after 0.01. You get a way different answer. 80 squared multiplied by 0.01. 64. That's way off. Don't round that off. Let's see. That's a classic example of watching the dangers of rounding off things. Keep your answer. You see, when you round off this 8, you reducing the precision by a lot, you know. Yeah, to keep a certain number of significant numbers. The significant numbers start here. So basically, you approximate to. That's a dangerous round off to do there. Don't do that. Don't do that one. Last one earlier. But you get to see some of the difficulties that could arise here. Notice it's the same technique. But since they put it in words, they had this squared, there wasn't a table. You have to know your stuff inside out. Once again, this is directly. I wish we had an inverse one. I think I have one on YouTube up, so you could go and check it out after this video. The h on the object is directly proportional to the square root of the perimeter. Oh gosh, so h is proportional to square root of p. Write an equation showing, so h is equal to kp, where k is the constant of proportionality, right? This is the variation. This symbol means varies. But if you have to use, if they say equation, you can't use this. You have to actually use that equal sign. But if you use that equal sign, we need to introduce the constant. Find for k when h is very repetitive, the same thing every single time. You're using two known values to find for k. So 5.4 is equal to k by 1.44. So k is equal to 5.4 divided by 1.44, which is how much? K is equal to 5.4 divided by 1.44, 3.75. Oh, I forget the square root sign. It's proportional to the square root. I'm trying to lose my marks here. Square root of 1.44. Nine over 2. We will get 9 over 2. 4.5. 9 over 2, hopefully. All right, let me just double check this because I find you all in hitting me anything there, boy. When h is equal to 5.4, p is equal to 1.44. Yeah. 9 over 2 is the same as 4.5. Yeah, so good. And so determine the value of h when p is 2.89. When p is equal to 2.89, what is the square root of that? 17. H must be equal to k, which is now 9 over 2 by the square root of 2.89. So 1.7 square root of 2.89. Yeah, 1.7 times 4.5, 9 over 2. What are we getting? 7.65. Let me see if that makes sense. H is equal to 7.65. Height more, perimeter more. Yeah, that's something reasonable. 7.65, was there units shown? No, units. All right, that is enough variation there. We get a good look at inequalities, we get a good look at variation. It takes us about an hour and 10 minutes. Hope you're feeling all algebra up. Feeling good about algebra, you could go and watch over this 5-part series. Before you watch anything on Netflix, watch this. Before I say love and blessings, as usual, let me just throw up the number. Those of you all who didn't register for the crash course yet, organize yourself, go and register. +1 868 472 4221. So I was giving away a lot of stuff to these SEA students, and I decided, you know what, SEA students always getting things. Let me give away to the Form 5s as well. But the problem was, I forget Form 5s. A whole Form 5 in our school is like 200 people. So I was calling out schools and saying, boom, bang, boom, boom, boom. The school. Not realizing when I say a school, I say 200 students and think, bro, I can bankrupt the student up here. No giveaways today, earlier. Love and blessings all again for today. Love and blessings is where you're getting for today alone. So we have a lot of schools to give away to, which actually adds up to a lot of students. So we got to go and find them books now. But don't worry, I'll get it. I say you get it, you will get it. But I really wasn't too sure about the number of students. There's when the admin started to do the maths on Midday and we started to send out, they're like, Anyhow, those of y'all who need to get the books, buy the books fast. They will be out soon. Love and blessings. Or you can WhatsApp any other information you need. Enjoy. WhatsApp and we get a link. Feel like putting up the stream here. Cost for the crash course is 300 TT. Cost for the book is $50 or $100, depending on what book you're getting.